Hi, in this video, we are going to look at a Putnam 1987 problem. It's a very interesting polynomial question and it ties in concepts of calculus with polynomials. So let's go get into it. This is saying that let P be a polynomial with real coefficients in 3 variables and let F be a function of 2 variables such that this result is true. P of ux, ui, uz is equal to u square f of y minus x and z minus x for all real x, y, z and u. Then there is some data that has been given for the p polynomial. P of 100 is 4, 010 is 5 and 001 is 6. And finally, the question says that if ABC are complex numbers such that P of ABC is 0 and mod of B minus A is 0, we have to find out mod of C minus A. So basically, you can approach this problem only if you are able to understand the nature of P and F and the connection between the two, right? So let's begin by looking at first this relation P of ux, ui, uz and is equal to u square of f of y minus x, z minus x, and try to get some conclusions from there, right? So first step, what I will do is try to understand if we set u is 1 and let's set x is 0. U is 1 and x is 0 in this relation, you would get P of, this becomes 0 y z is equal to u square f of y and z, right? So basically we are getting P of 0 y z is equal to u square f of y z, right? Now we know that P was a polynomial in x, y, z, right? P is a polynomial. So this side is a polynomial in y and z, right? So that implies that your f of y and z, right? F of y and z should also be a polynomial. By the way, I missed out here. I can put u is 1 here, right? So this will become actually just equal to f of y and z. So if the left-hand side is a polynomial, obviously f of y z is also a polynomial, right? That is an important idea here because we'll try to write down f in a certain way. So for now, just keep in mind that f of yz has come out to be a polynomial, right? Now, the second step that we would try here is let's think of what is f of uy and uz, uy and uz, right? So basically, instead of f of y and z, instead of y I am putting uy, instead of z I am putting uz, right? So that is clearly going to be equal to p of 0 comma uy comma uz, right? Why? Because this equality is true for all real x, y, z, q. Therefore, if I replace y with uy and z with uz, I will get p of 0 uy uz, right? Now, from the first result, p of 0 uy uz, we should get this should be equal to, I will just write it here, P of 0 uy uz should be equal to u square f of y and z, right? U square f of y and z. We are just using the first result. Excuse me. So from this result, if I put uy uz, we are getting x is 0 basically. So you'll get u square f of y and z, right? Now keep in mind this connection f of uy uz is becoming u square f of y and z. F of uy uz is becoming u square f of y and z. So this is the definition of a homogeneous polynomial. We already know that f of yz is a polynomial, right? F is a polynomial, but this is the definition of a homogeneous function, right? And the function is homogeneous with degree 2 here because you are getting u square outside and f of yz here. So the 2 here is the degree of the homogeneous function, right? So what we have concluded so far is that f is homogeneous in y and z and has degree 2. How did we get this? Because we were able to prove that f of uy uz was equal to p of 0 uy uz and that was equal to f of u square into f of y and z, right? This is what we have gotten so far. We got this by setting u is 1 and x is 0 in the first equation, and from there we had gotten f of y and z is equal to p of 0 comma y and z, right? From there we got this. So I'm just recapping everything so that you understand where it's coming from. So we have finally concluded that f is a homogeneous polynomial in y and z and has degree 2, right? Now, if p of xyz was written as f of y minus x and z minus x, now think about it. How can you make a homogeneous polynomial like this? F is a function of y minus x and z minus x, and it has to be homogeneous with degree 2, right? So the most general homogeneous function of y minus x and z minus x would be a times y minus x whole square, because I want to keep degree 2. So I have put y minus x whole square plus b times y minus x into z minus x plus c times z minus x whole square. Think about it. This is the most general 2-degree polynomial which is homogeneous that you can construct here, right? So we are basically getting a tentative expression for p of xyz, right? P of xyz is coming like this. The only thing unknown here is constant a, b, and c, right? We have gotten this tentative expression because we know that this is coming out to be a 2-degree homogeneous polynomial. So we are just writing that as f, right? ABC is unknown, and now the question has given you some data. The question has given you P of 100 is 4, P of 010 is 5, and P of 001 is 6, right? If I use this data now in the problem, I will be able to find ABC, right? So I will just try and use that data here. So putting 100 in this equation, we get 4 should be equal to 1 for x and 0 for y and all. So you're getting 4 is equal to a plus b plus c, right? You can put this x as 1, y as 0, z as 0 in this equation. You should get this. Then similarly, 5 is equal to p of 0, 1, 0. And that will come out to be, you are putting x as 0, y as 1. So you'll get a here. X as 0, y as 1, and z as 0, right? So this part becomes 0, so this term vanishes. And similarly, z minus x is 0, so that term also vanishes. So a is 5. And similarly, 6 is equal to p of 0, 0, 1. So therefore, that is coming out to be c, right? So we are getting a is 5, c is 6. And from the first equation, now we get b is equal to minus 7, right? So that basically gives us the p function completely, right? We know all the 3 unknown constants and we have the p function, right? Now our question is to try and find out the second part of the problem, right? Second part of the problem said that if p of ABC was equal to 0, where ABC were complex numbers, then mod of b minus a was given, and that was equal to 1, I think. Mod of b minus a was, no, mod of b minus a was equal to 10, right? Then you had to find mod of c minus a. So we had p of ABC equal to 0, mod of b minus a was 10, and we had to find mod of c minus a, right? That was the question. So let's try to understand what happens if I put p of ABC equal to 0, right? So my p polynomial, p of ABC equal to 0, will be equivalent to, you have a was 5, so 5 times you have b minus a whole square, minus 7 was b was minus 7 if you recall. So this was b minus a into c minus a, and plus 6 times c minus a whole square equal to 0, right? So this is my condition, and I also know mod of b minus a is equal to 10. So how do I try to solve this? Like I can divide by the square of b minus a whole square. So I'll get 5 minus 7 c minus a by b minus a plus 6 times c minus a by b minus a whole square equal to 0. And this looks like a quadratic in this term. So let's call m is equal to c minus a by b minus a. And we are getting a quadratic like this, 6m square minus 7m plus 5 equal to 0, right? The product of the roots here, m1, m2 is equal to 5 by 6, right? The product of the roots is 5 by 6. And now we can say that what will be the product of the roots here? If you think of this quadratic, actually, the quadratic has discriminant is less than 0 because 49 minus 20 into 6. Discriminant is less than 0. So this quadratic has both roots are complex. Both roots are complex, right? And if I have two complex roots, they will be conjugates of each other. So m1, m2 is actually mod of m1 square is equal to 5 by 6, right? Do you understand what I'm saying? I'm basically saying that the roots will be of the form a plus ib, a minus ib. So when I do product of the roots, it will become a square plus b square, which is mod of a plus ib whole square, right? So that's what I'm saying. M1, M2 is mod of M1 whole square. So that implies that mod of M1, one of the roots, is equal to root 5 by root 6, right? So what is mod of M1? Mod of M1 would be this value, right? Mod of C minus A by B minus A is coming out to be root 5 by root 6, right? If this is coming, then we immediately get mod of C minus A is equal to root 5 by root 6 into 10. That becomes 10 times root 5 by root 6. Or you can simplify that a little bit and write it as 5 root 30 by 3. So that turns out to be our answer, mod of C minus A. Notice that I have done a shortcut here by saying that this is a quadratic in M and we can take M1, M2 is equal to mod of M1 square. You can do it in a traditional way also. You can solve this quadratic and find the different values of C minus A and B minus A, right? There will be two roots of this quadratic. C minus A by B minus A could be either one of those two roots, right? So when you do a product of those roots, you will get mod of C minus A by B minus A whole square. That should be equal to 5 by 6. You will get the same result even if you try to solve the quadratic in a general way. Remember that C minus A and B minus A are all complex numbers here, right? So that solves the problem. Ultimately, the problem was pretty easy if you were able to find the P function, right? We were able to find the P function by noting the relationship between the P and the F that was given in the beginning. And we realized that the P function was a polynomial and it was a degree 2 homogeneous polynomial, right? So if you are still confused, please go back to the earlier part of this video where we discussed how we came to the conclusion that it was a degree 2 homogeneous polynomial. It's a very interesting problem because first you have to analyze the polynomial and only if you come to that conclusion can you find the actual polynomial because only three pieces of data was given in the problem. The value of the function at 0, 0, 1, 0, 1, 0 and 1, 0, 0 were given. So unless you can have a polynomial expression with three unknowns, you cannot figure out the answer, right? So hopefully you learned something from this video. If you like the content, please subscribe to the channel and stay tuned for the next few videos. I'll be bringing more interesting problems and hopefully you'll learn from each of them. See you next time.